Okay, probably you were able to see my white screen on there. I'm going to explain the meaning of the confidence limit and the relation of this confidence limit with the level of significance. So first of all, let me try to begin with the confidence limit section. I said that when mod z is less than 1.96, so less than or equal to 1.96, this class is the continuation of the previous session, session 1 of today's class. Okay, so I said that when mod z is less than or equal to 1.96, you are going to accept your null hypothesis at some level of significance, which is 5%. Okay, so what is the meaning of this? Why it is called a 5% level of significance, and why this limit is called the confidence limit? Now, that I'm going to explain right now. Now you see, when I write that mod z is less than or equal to 1.96, this mathematically it means that the value of z is actually lying between plus 1.96 and minus 1.96. What I'm going to do right now is that I'm going to calculate its probability that z will lie within this region. Calculate the probability that your standard variable z is lying inside this region. So we get probability of minus 1.96 to plus 1.96. That probability I'm going to find out using the help by taking the help from the normal table that I shared with you in one of my previous classes. Now, how to calculate this probability? So first of all, what I'm going to do is that I'm going to draw the normal curve. I'm going to put the point minus 1.96 over there and plus 1.96 over there. And this point is z equal to 0 because you know that the standard normal variate mean is always set to 0. Now, just look at your note number 8. In the note number 8, try to locate the probability which is given as z less than or equal to 1.96. And tell me what is the probability there. If you have located the note and in the normal table, I think you will be able to find out the probability. What is the probability when z is less than or equal to 1.96? Try to find this probability from the normal table. Try to find out the probability from the normal table and write in the chat box. For this, what you have to do, you have to select the point from the row. The row heading should be 1.9 because you know that this 1.96 can be written as 1.9 plus 0.06. That becomes 1.96. So this is the row that you have to mark, and that is the column that you have to mark. Now, Oyan Banerjee has already given me the value. It is 0.975. Very good, Oyan. Thank you so much. Now you see that when I write, sorry, this is not 0.975. Let me write it properly. Now from the normal table that I'm going to find out, from normal table, we have found that probability that z is less than or equal to 1.96 is 0.975. What does it mean? It means that z is lying between the point minus infinity and 1.96. 1.96 is included. So actually I'm considering this region. This region's probability is known to me. If you have properly understood. And I want to find the region of marked by that I'm going to shade over here. I'm going to find the region which is lying between minus 1.96 and plus 1.96. So this is the region I am interested about. So this is the region I'm interested about. So what I'm going to do is that, first of all, let me try to find out the probability that Z lies between 0 and 1.96. This probability, just look at the normal table. This probability can be calculated by subtracting the probability that Z lying between minus infinity and 0 from this region. So I'm going to, from the yellow shaded region, I'm going to subtract the region which is marked by the green shade. If I can do so, then this probability will come out. The probability of this section will come out. So we know that this probability is 0.975. And since it is the normal curve and Z equal to 0 is the median, so this probability is 0.5. This probability is 0.5. And if I subtract 0.5 from 0.975, then how much we get? We get 0.475. We get 0.475. So probability that Z lying between 0 to 1.96 is actually 0.475. Okay. Now, since we are dealing with a normal curve, since Z is normally distributed, then what is happening? That probability of this section, I'm again drawing the diagram. This is your point minus 1.96, and this is the point which is plus 1.96. So probability of this section and probability of that section, they are actually same, because Z equal to 0 is the median. So this implies that probability that Z lying between 0 and 1.96 and probability that Z lying between minus 1.96 to 0, they are basically same, and which is equal to 0.475. Okay, and this implies that probability that Z lying between minus 1.96 to plus 1.96 is obtained by adding the two probabilities, the two respective probabilities. So I'm going to add the two respective probabilities like this. And this probability, you know that it is, both of them are equal to 0.475. And if I add the two terms, we get 0.95. So what we say that there is 95% chance that Z will lie between the points minus 1.96 to plus 1.96. Okay, and this limit, that's why this limit is actually called the confidence limit. I'm 95% confidence that Z will lie between these 2 points. Okay, and what will be the probability? What will be the probability that probability of Z is less than minus 1.96 or probability of Z greater than 1.96? In both the cases, the probabilities will be 1 minus probability of Z lying between minus 1.96 to plus 1.96. Why? Because the curve is a normal curve. That's why. In both the cases, you are going to subtract the respective probability from the total probability, and which is 0.05. Here also it is 0.05. And therefore 0.05, actually what we call 0.05 is the level of significance. So what we have got from here is that level of significance is actually a kind of probability that we are calculating. Level of significance is a kind of probability that we are calculating. So what is level of significance? It is a probability with which we reject the null hypothesis. Okay, very briefly speaking, level of significance is a kind of probability with which we reject the null hypothesis. 5% level of significance means there, from the sample that you have chosen, 5% of the sample is actually 5% of the total sample is actually responsible for rejection of the null hypothesis. So what is level of significance giving me? 5% level of significance. This word, this term that I'm using, it means among the total sample of some size, 5% of the sample is actually responsible for rejection of H0. 5% of the sample is actually responsible for rejection of H0. Similarly, you can define 1% level of significance also. How can you calculate? This is a very brief homework that you can go for. Try to find out what is the probability that Z will lie between minus 2.58 and plus 2.58. Try to find this probability from the normal curve. Also try to find the probability that Z will lie between minus 2.3 and plus 2.3. Try to find out the probability that Z lies between minus 1.645 and plus 1.645. All these probabilities that you can calculate accordingly. Okay, so just you can do this brief homework. The process of doing it be exactly same, that in exactly the same way that I have shown you just now. Now, in the previous session we did a problem. In the previous session we did a problem where the sample size was 900 and the sample mean X bar was 3.4. Population mean mu was 3.25. Standard deviation S, sample standard deviation was 2.61. Population standard deviation was 2.61, and we tested H0 when mu is equal to 3.25 and H1 when mu is not equal to 3.25. According to the sample, we actually have found that our null hypothesis got accepted. What will happen? The question is, what will happen if your null hypothesis is rejected somehow? What will happen if your null hypothesis is rejected? How can you conclude? How can you conclude about the population mean then? Because at the end of the day, we are doing this calculation to guess something about the population parameter. Either we are interested about the population mean or we are interested about the population standard deviation. But we are taking the pain of this calculation just to guess, just to accept, to say something about this population mean. Samples are only helping us in this regard, but we are not interested about sampling. We are only interested about the population. But suppose during the testing of hypothesis and during the process of during this process we have actually rejected the null hypothesis, because it is not always possible to select the 900 members or more than that or less than that. The selection of sampling is actually takes lots of time, lots of amount, lots of energy, lots of money, lots of manpower, lots of dedication, which we lack. So the question is, if the null hypothesis is accepted, it's okay, no problem. We are satisfied, we are happy. But if it gets rejected, then do I have to start from the scratch and select the sample once again by utilizing my manpower and money? Then this is a time-taking process. Suppose we do not have much time left. Okay, we have to declare something. Then is there any process by which we can guess the null hypothesis, by which we can get the population mean? The answer is yes. What we do is the following. Suppose true population mean is not known to us. True population mean is not known to us. Then what we do, we try to find an interval in which the population mean may fall, okay, or may fluctuate. So how can I do it? How can I do this? The way is the following. Okay, so in this case, what we know, we already know that capital Z lying between minus 1.96 and plus 1.96. From our previous calculation, we know that it is 0.95. Since true population mean is not known, I am going to calculate, we are going to calculate the confidence limit of the population mean mu. So how can I do this? The limit will be calculated in the following manner. Therefore, since suppose we know that Z has to fall between 1.96 minus 1.96 and plus 1.96. But what is Z? Our Z in this case is our x bar minus mu by sigma by root n. This is our Z. Sample size is positive, so square root of the sample size is also positive. Standard deviation is positive, so the ratio of standard deviation and the square root of the sample size is positive. So denominator is positive, and therefore we can multiply both the sides by, we can multiply all the sides by this positive quantity. So from there we get minus 1.96 multiplied by sigma by root n less than or equal to x bar minus mu 1.96 into sigma by root over n. Okay, and this is equal to, now we want to guess the confidence limit for mu. So what we are going to do is that we are actually going to multiply all the sides by -1. Let's see let us see what happens then. If I multiply all the sides by -1, then we will get this quantity will become -1 multiplied by this will become 1.96 into sigma by root over n. Inequality will change its direction. You get mu minus x bar in between. This will be greater than or equal to minus 1.96 sigma by root n. Then what you can do, you can add X bar on all the sides. So if I do this, you will be getting X bar plus 1.96 sigma by root n greater than or equal to mu greater than or equal to X bar minus 1.96 into sigma by root n. This is equal to, this is same as writing X bar minus 1.96 sigma by root n less than or equal to mu less than or equal to X bar plus 1.96 into sigma by root n. So, so we see that we know X bar, we know sigma, we know root over n. Then we can easily calculate this lower limit. And we can easily calculate this upper limit. Okay. And we can guess in which limit this mean value of the population will fluctuate. So please take the pain to calculate the lower limit and the upper limit in this case and write in the chat box. So please write in the chat box what comes out with respect to our given problem. Here you have your X bar as 3.4, your sigma as 2.61, your n as 900. So give me the value of the lower limit and give me the value of the upper limit. And this is done when mu is not known, or rather cannot be guessed. So I'm waiting for your reply. Are you calculating the thing? Yeah, so I have got my result. The lower limit is 3.22948 and the upper limit is 3.57052. So ultimately, after the end of these two sessions, what have we learned? What we are doing in this particular class? Let me explain this thing from the beginning very briefly. The process is, the entire process of statistics is this. The basic objective of statistics is to study the population. Study population. We want to study the population. Okay, so that we can bring change into it if it is required. For this process, in the basic level, we are actually learning about combinatorics. That means in our school level, we are learning about combinatorics. After that, what we are doing, we have actually found that our physical system doesn't behave deterministically. Rather, our physical system is behaving probabilistically. So we learn about probability theory, and to learn about probability theory, sometimes we need the help of the combinatorics. Sometimes we need not. Once the physical system is studied with respect to probability theory, what we do, we try to find out various probability distributions. We know that there are two types of probability distributions. One is discrete and another is continuous. And in discrete, there are several cases. In continuous, there are several cases. Why am I studying this probability distribution? Why am I studying this? Because we know that our population follows some probability distribution. And if the probability distribution of the population is known, then we can find the population parameter, or we can guess about the population parameter. I shouldn't use the word find, I should use the word guess rather, because suppose our population behave binomially, we know that the population parameter, that means the mean is NP and variance is NPQ. If it is Poisson, we know that it is lambda and it's lambda, like this. So once population distribution parameter is guessed, then we want to test. After this, what we want to do, we want to test the population parameter. Test the population parameter. Okay, whether it is true or false, whether our guessing is true or false. Then the question comes that, can I do this with the help of sample? Can I do this with the help of sample? Can sampling be done? No. Before that, we need to know, can I do it on the basis of sample? That means which sample observation or a sample, sample observation estimates which population observation. Okay, that we have to know. That this is very important. So for this, we actually study the estimation theory. For that, we actually study the estimation theory. And it has been found in estimation theory that sample mean X bar correctly estimates population mean, but sample standard deviation small s doesn't correctly estimate population standard deviation. Rather, if we divide this quantity by n-1, this correctly estimates the population standard deviation. All these things are actually taught in the estimation theory. Estimation theory is the gap of your syllabus. It is the gap in the syllabus. In the syllabus, if you open the syllabus, you will find that in BSM 201, this estimation theory is missing. Once you are sure that, yeah, we can draw conclusion about population using the sample statistic, then we actually go for, once this is verified, we actually go for sampling and its distribution. We go for sampling and its distribution. We have to know various process of finding the samples, because there are various processes by which sample can be found. Purposive sampling is there, random sampling is there, simple random sampling is there, cluster sampling is there, multi-stage sampling is there. Depending upon the physical system and our demand, the appropriate sampling process is actually chosen. Once sampling is done, we set up our hypothesis and we go for hypothesis testing. We go for hypothesis testing. Either we select our, we accept our hypothesis or we reject our hypothesis. If we accept our hypothesis, then it is okay. If we reject our hypothesis, then we again go for estimation theory. And we try to estimate the population parameter. That estimation is called the interval estimation. And after that, once we learn all this, we go to the finishing line, which is called SQC. It is called statistical quality control. How to maintain the quality using all the knowledge that we have gathered. Okay. And then when we actually stuck somewhere, we again go to the basic level and this cycle is run. This is the basic diagram that we follow, that is actually followed in various statistical analysis. Now in these different sections, various studies are made. First of all, we can study the entire thing with the help of univariable. Then we can study the entire thing with the help of bivariable, or we can study the entire thing with the help of multivariable. And various other analyses like are hidden here and there. Regression analysis is one of them. Okay, so this is the cycle that you have to keep in mind. So that is actually being happened because I'm taking the class of statistics, and sporadically, if you may think that all the topics are being taught sporadically, that means probably since you're learning it for the first time, you will not be able to locate what is happening. Sometimes sir is doing this thing, and sometimes sir is doing the other thing. We do not know what is he doing at what time. Okay, so what is the basic connection about all these related to probability theory? So I have intentionally drawn this particular cycle for you. If you remember, try to remember this particular cycle. And this cycle will help you to identify the basic need of the statistics. In statistics is actually studied with the help of probability theory. Okay. So since you have been doing the classes since the morning, and my time is also running out, it is 6 minutes 53 seconds left. I think I shouldn't stretch further today. Okay, so I'm going to stop at this point. I'll upload the video very soon, and I'm asking all the students who haven't gone through my earlier 2 videos on statistical hypothesis, please go through that first, and then you go through the current one. Okay, with this, I'm going to conclude my today's session. Hope you have enjoyed. See you soon. Till then, bye.